Hello guys, I'm Farzana and welcome back to Artificial Intelligence. Today topic is gradient descent. Yes, what you guys guessed is right. It's all about max theory, max theory, max. So focus. If focus missed, cool. Pass, play, replay. But for sure, we are going to have fun for next few minutes. How? Max is fun. Yes, guys, really, Max is fun. So I feel how I enjoy. You guys also going to enjoy for sure. Without further delay, let's in. Before we move into gradient descent, in last session we gave a lot of hype about deep learning. So you guys all thought everything is cool in deep learning, but it has its own limitations. But no worries, we will learn how to handle and overcome all these limitations in this session and in upcoming session. To understand gradient descent better, let's look out how training happens and what we learned so far in machine learning. Let's start with machine learning terminologies. Here weights are denoted as W1, W2, W3. Features which is nothing but an input as X1, X2, X3. Target which is our predicted or output variable, it's Y. What is bias in machine learning? It is a mathematical convergence which prevent the line from going to origin. Let's look how training happens in machine learning algorithm with the help of house price prediction. This is common and familiar use case, right? Here we calculated the loss. Loss is nothing but actual and predicted value, which is a difference between the actual and predicted values. Let's understand with a simplest formula. This is nothing but a loss function. Why sum of squares? We want to punish the large deviation. 500 is nothing but a sample data. 2 is a mathematical convergence. Few will use to, few won't. So it's up to you whether we can use or we don't want. There is nothing going to change in the output. If you want a complex form, yes, here it's the complex form. But we are the smartest guys, right? We understood the formula in the smartest way. Once we apply this formula, we got this loss function. But what's our aim? Our aim is to make this loss as close to zero. So what's the solution? We want to adjust the combination of weights and bias to get loss close to zero. Why weight and bias? We don't have an option to adjust x and y. We have the option only weight and bias. So this is what the idea and this is what we learned so far in linear regression till now. Usually this is not pretty. Why? For example, if we take up W1 equal to 1, W2 equal to 2, W3 equal to 4, if it is not close to 0, then what to do? Again, I'm opting with W1 equal to 4, W2 equal to 7, W3 equal to minus 8. If this is also not close to 0, again to fit with base combinations, we have to change the value. So we have to opt n number of combinations with n number of trial and error. It will take lot of time. That's where our hero comes into picture. Who's that? Yes, guys, you guessed correct. It's a gradient descent. Cool. I hope. So far everything is clear. We continue the remaining part in next session. Hope the content is useful. If you like, please do like, share and subscribe. Catch you soon in the next tutorial. Till then, Fazana signing off.